So today we're going to be going over solving systems of linear equations using substitution. With these, a lot of times they'll give you one equation that one of the variables is solved for. Sometimes they won't. If they don't, you're going to have to use one of the equations to solve for one of the variables and then plug in the expression for that variable into the other equation. So like, for example, number 1, it gives you y is equal to 6x minus 11, as well as negative 2x minus 3y is equal to negative 7. Because this one has your y is equal to that 6x minus 11, you're going to plug that expression in for y in the negative 2x minus 3y is equal to negative 7. So this is going to give us negative 2x minus 3 times 6x minus 11 is equal to negative 7. We're going to distribute the negative 3. So that gives us negative 2x minus 18x plus 33 is equal to negative 7. We're going to combine like terms on the left. So the negative 2x minus 18x is negative 20x plus 33 is equal to negative 7. We're going to subtract the 33 from each side. This leaves us with negative 20x is equal to negative 40. From here, just divide each side by the negative 20, and you get that x is 2. Now that you have what x is, take what x is and plug it in for y, plug it in for x in the y is equal to 6x minus 11. So y is equal to 6 times x, which is 2 minus 11. The 6 times 2 is 12. Minus 11 gives us that y is equal to 1. You have an x, you have a y. Give an ordered pair with your x and your y. So that's 2, 1, and that is your answer. With these, once you get your ordered pair, that is your solution. You should be able to plug in the x for x in both equations, plug in the y for y in both equations, and solve them both and get true statements for both of them. If you're not getting the true statements, then you know one of your numbers, if not both of them, are incorrect. For number 2, you have y is equal to negative 3x plus 5, as well as 5x minus 4y is equal to negative 3. That top equation is solved for y, so we can take the negative 3x plus 5 and plug it in for y in the bottom equation. So this is going to give us 5x minus 4 times negative 3x plus 5 is equal to negative 3. We're going to start by distributing that negative 4. So it's going to give us 5x plus 12x minus 20 is equal to negative 3. Combine your like terms of the 5x and the 12x to get 17x minus 20 is equal to negative 3. And then add your 20 to both sides to get 17x is equal to 17. Divide each side by the 17, and you have that x is equal to 1. Now that you have x, plug it in and solve for y. So y is equal to negative 3 times x, which is 1, plus 5. The negative 3 times 1 gives us negative 3, plus 5 is 2. So if your x is 1, your y is 2. That's the ordered pair, 1, 2. For number 5, you are given y is equal to negative 2 and 4x minus 3y is equal to 18. This is one of the easier ones. You have that y is equal to an actual number, not an expression. So you're just going to take that negative 2, plug it in for y in the 4x minus 3y is equal to 18, and solve for x. So it's going to give us 4x minus 3 times negative 2 is equal to 18. The negative 3 times negative 2 is 6, so that's 4x plus 6 is equal to 18. We're going to move the 6 over by subtracting it from each side, so it's 4x is equal to 12. Then divide each side by the 4, and you get that x is 3. If x is 3, y is negative 2. That gives you 3, negative 2 for your solution. For number 7, we have negative 4x plus y is equal to 6, and negative 5x minus y is equal to 21. Neither of these equations have an x is equal to or a y is equal to. So if I were you, I'd pick the equation that is easiest to solve for one of the variables. If you look at the top equation, you have a positive y that does not have a coefficient other than that invisible 1. So you would take that equation and solve it for y. If you take the negative 4x plus y is equal to 6, the only thing that you have to do to solve for y for this one is to move the 4x over. So we would just add it to both sides. So this gives us y is equal to 4x plus 6. You take the expression 4x plus 6, you plug it in for y in that bottom equation. So you have negative 5x minus the expression for y, so 4x plus 6 is equal to 21. That negative in front of the parentheses needs to be distributed in. So this gives you negative 5x minus 4x minus 6 is equal to 21. If you combine like terms here, that negative 5x minus 4x is negative 9x minus 6 is equal to negative 21. You're going to add the 6 to both sides. So this gives you negative 9x is equal to negative the 21. This becomes 11. This becomes 1. So that's negative 15. From here, yes. I don't know why it did. It should be positive. Thank you for pointing that out. That's why I was getting a funny answer here. So this should be a positive 21. There we go. All right, so then we still combine like terms to give us the negative 9x minus 6 is equal to positive 21. From here, add the 6 to both sides, so now this is going to work out a lot better. Negative 9x is equal to 27. Divide each side by the negative 9, and you get that x is negative 3. From here, because you've solved one of those equations for y from the beginning, take the negative 3, plug it in for x, and solve for y. So this is going to give you y is equal to 4 times x, which we said is negative 3, plus 6. The negative 3 times 4 is negative 12, plus 6 gives us a negative 6. It is a negative 3. So the negative 3 for your x and the y of negative 6 gives you the ordered pair of negative 3, comma negative 6. For number 9, you have 5x plus y is equal to negative 2, and negative 3x plus 6y is equal to negative 12. Which of these do you want to solve for what variable? The first one for what? X or y? Okay, so if we have negative 5x plus y is equal to negative 2, you want to get y by itself. We're going to add the 5x to both sides. And we just have y is equal to 5x minus 2. Take the 5x minus 2, plug it in for y in the bottom equation since you did not work with that one yet. This is going to give you negative 3x plus 6 times 5x minus 2 is equal to negative 12. Distribute in the 6. This gives us negative 3x plus 30x minus 12 is equal to negative 12. If you combine your like terms here, the negative 3x plus 30x gives us 27x minus 12 is equal to negative 12. You're going to move the 12 over, so add it to both sides. When you do that, you're left with 27x is equal to 0. You still got to get x by itself, so divide each side by the 27. 0 divided by anything is 0, so x is equal to 0. Now that you have for x, solve for y. One of those equations you solved for y, so plug it in for the x in that equation. So you're going to have y is equal to 5 times x, which we said is 0, minus 2. 5 times 0 is 0, so y is equal to 0 minus 2. That gives us y is equal to negative 2. So that x is 0, the y is negative 2. Our solution is 0, negative 2. For 11, we have x plus 3y is equal to 1, and negative 3x minus 3y is equal to negative 15. Which of these equations do you want to use to solve for one of the variables? The bottom. I would use the top one. You already got x to where it has a coefficient of 1, so I would use the top one and just solve for x. So x plus 3y is equal to 1. You could have used the bottom one. It's fine. It would have been the same. Yeah, you're going to be working with the same type of problem. So you could have. If you use the bottom one, you're just causing more work for yourself. That's all. So for using the top one, we would subtract the 3y from both sides. You get x is equal to negative 3y plus 1. So take this, plug it in for x in that bottom equation. So you have negative 3 times negative 3y plus 1 minus 3y is equal to negative 15. Distribute the negative 3 into the parentheses. It gives us positive 9y minus 3y is equal to negative 15. Your like terms get combined to give you 6y minus 3 is equal to negative 15. We add the 3 to both sides. We get 6y is equal to negative 12. Then we divide each side by the 6, and we have that y is negative 2. If y is negative 2, plug that in for y, and x is equal to negative 3y plus 1, and solve for x. So you're going to have x is equal to negative 3 times negative 2 plus 1. Negative 3 times negative 2 is positive 6 plus 1 gives us an x of 7. If x is 7, y is negative 2. Our solution is 7, negative 2. For 13, you have negative 3x plus 3y is equal to 4, and negative x plus y is equal to 3. Which of these equations do you want to solve for one of the variables? The bottom. What do you want to solve for on the bottom, the x or the y?
The y.
The y. Okay, so exactly, you're going to add x to both sides. So it gives you y is equal to x plus 3. If y is equal to x plus 3, plug that x plus 3 in for y in the top equation. This is going to give you negative 3x plus 3 times x plus 3 is equal to 4. Distribute your 3 in. So negative 3x plus 3x plus 9 is equal to 4. When you combine like terms, what happens to them?
They cancel out.
They're opposites, so they cancel. So you just have 9 is equal to 4. Is this a true statement?
No.
No, it's not. When you get something like this where you get a false statement anywhere in your solving, automatically, it's no solution. For 15, we have 6x plus 6y is equal to negative 6, and 5x plus y is equal to negative 13. Which of these equations do you want to use to solve for one of the variables?
The
Bottom. What do you want to solve for?
y.
Okay, so we're going to move the 5x over. We'll subtract it from each side. So that gives us y is equal to negative 5x minus 13. Take the negative 5x minus 13, plug it in for y in the top equation. So it's going to give you 6x plus 6 times negative 5x minus 13 is equal to negative 6. Distribute your 6 in. The 6x stays. The 6 times the negative 5x is negative 30x. The 6 times negative 13 is negative 78 is equal to negative 6. What are you going to do next? Combine your like terms. So that's negative 24x minus 78 is equal to negative 6. If we add the 78 to both sides, you have negative 24x is equal to what? 72. If we divide each side by the negative 24, 72 divided by negative 24 is what? Negative 3. If x is equal to negative 3, plug it in for x, and y is equal to negative 5x minus 13, and solve for y. You're going to have y is equal to negative 5 times negative 3 minus 13. What is negative 5 times negative 3? 15 minus 13 is 2. If your x is negative 3, your y is 2. That gives you the ordered pair of negative 3, comma 2. For number 17, you have negative 3x minus 4y is equal to 2, as well as 3x plus 3y is equal to negative 3. Now, if you look at both of these equations, neither of these equations have a variable that has a coefficient of 1 with it. So you got to look at this and try to see which is the easiest to solve for. If you look at the bottom, you have coefficients and a constant, all of 3. So that would probably be the easiest one to use. Using the bottom one, would you like to solve for x or y? You want to solve for y? So to solve for y, we're going to move the 3x over by subtracting it from each side. We have 3y is equal to negative 3x minus 3. Then we just divide each side by 3. Remember, when you divide each side by that 3, you're dividing every term by that 3. So the negative 3x divided by 3 is just negative x, and negative 3 divided by 3 is negative 1. So if y is equal to negative x minus 1, plug that negative x minus 1 in for y in the top equation and solve for x. This is going to give us negative 3x minus 4 times negative x minus 1 is equal to 2. Distribute your negative 4. You're going to have negative 3x plus 4x plus 4 is equal to 2. Combine your like terms. That leaves you with x plus 4 is equal to 2. Then move your 4 over by subtracting it from each side to get that x is equal to negative 2. If x is equal to negative 2, plug that in for x, and y is equal to negative x minus 1. So it's going to give you y is equal to the opposite of negative 2 minus 1. That gives you a positive 2 minus 1, which is just y is equal to 1. If x is negative 2 and y is 1, our solution is negative 2, comma 1. For your last question, number 19, you have negative 5x minus 8y is equal to 17, as well as 2x minus 7y is equal to negative 17. Which of these equations would you like to solve one of the variables for? I would use the bottom one, and if it was me, I would solve for x, just because to me that's easiest. So if I was to use the bottom one and to solve for x, I would add the 7y to both sides to start with. That would leave us with 2x is equal to 7y minus 17. And then just divide each side by the 2 to get that x is equal to 7 over 2y minus 17 over 2.
If we did the other one, would there be a fraction?
It would still be, yeah, it would still be the fraction. So if you did, what do you mean the other one? The other equation or the other variable?
The other equation.
Yeah. So like if you were to use the negative 5x minus 8y is equal to 17, and let's just say you want to solve for x, you would add the 8y to both sides and be working with negative 5x is equal to 8y plus 17. Then divide by negative 5. So it's just x is equal to negative 8 over 5y minus 17 over 5. I don't like using that one because then I have a higher denominator. So when I'm finding my like denominators to add and subtract fractions, it's going to be harder. So I would rather have used the bottom one. So I have a denominator of 2 instead of 5. That's all. So from here, I'm going to work with the x is equal to 7 over 2y minus 17 over 2 and plug that in for x in the top equation. So I'm going to take this, plug it in for x in the top equation. This is going to give us negative 5 times 7 over 2y minus 17 over 2 minus 8y is equal to 17. Distribute your negative 5 in. This gives you negative 35 over 2y plus 5 times 17. The 5 times 7 is 35. Carry the 3. The 5 times 1 plus 3 is 8. So 85 over 2 minus 8y is equal to 17. Do you want to work with your fractions? I wouldn't. So what I would do is I would multiply everything by your least common denominator. Your least common denominator here is 2. So everything gets multiplied by the 2. It gets distributed in. The 2 times negative 35 over 2y is just negative 35y. The 2 times 85 over 2 is just 85. The 2 times negative 8y is negative 16y. And the 2 times 17 is 34. Now you don't have to work with your fractions, and it's going to be a little bit easier for you.
Wait, so, like, multiplying it by 2 doesn't take it, like, the whole thing?
It doesn't change the value of anything.
So it just takes away the 2?
It just takes away your fractions, so you don't have to work with them.
Okay.
You may get a y that's equal to a fraction. That's fine. But at least while you're working with the problem to solve for y, you're not working with the fractions. Okay. So from here, combine your least common, or sorry, combine your like terms. You have the negative 35y and the negative 16y. When you combine them, what do you get? 5 plus 6 is 11. Carry the 1. The 1 plus 1 plus 3 is 5, so that's negative 51y. Plus 85 is equal to 34. Subtract your 85 from both sides. Remember, different signs, you're subtracting a larger number from a smaller number. It's going to be negative. 5 minus 4 is 1. 8 minus 3 is 5, so it's negative 51 is equal to negative 51y. Divide each side by the negative 51. And you get that y is equal to positive 1. If y is equal to positive 1, plug that in for y, in that x is equal to 7 over 2y minus 12 over 7. This is going to give us x is equal to 7 over 2 times 1 minus 17 over 2. So that's just 7 over 2 minus 17 over 2. What is 7 minus 17? Negative 10 over 2 simplifies to be negative 5. So if your x is negative 5 and your y is 1, the solution is negative 5, comma 1. If you plugged the negative 5 in for x and the 1 in for y, for like the top equation, you'd have negative 5 times negative 5 is 25. Then negative 8 times 1 is negative 8. 25 minus 8 gives you the 17. If you have 2 times negative 5, that's negative 10. Minus 7 times 1, that's negative 7. Negative 10 minus 7 is negative 17. True statements for both, so you know your answer is definitely correct.